Testing. Testing. Hello. Hello. Can you hear me? Oh, okay. Okay. Wait. We'll get this thing started soon. Okay. Just hang with me. We're almost there. Actually, get ready for the biggest star of the show. Hello. Hello. Yes. Thank you. Thank you. Thank you. I am Roland. I am the official spokesmonster for Chipperdoodles, Chippy Doodles. Yes, yes. Yes. Okay. So today, as you can see up screen, we are going to be talking about raster hand drawing your own circuit. Well, okay. I won't be doing the talk. I know I'm beautiful. I know you want to look at me for the whole hour. I know. But I can't be up all the time. I can just be up some of the time. It's very hard work taking all the love and adoration from the fans. I need my beauty sleep for very long periods of time. But I love you because I know you love me. That's how it works. Okay, thank you. Okay, let's get ready. We'll say hi to Bulbul, also known as Chipperdoodles, who will show up magically. Yeah, I'll be up. Don't worry. Will show up magically from under whatever this is. A desk, a sales counter, I think. Yeah, okay. Okay, I'll be up. Okay, go down. I don't want to go down. Go down, roll. Okay. Ah! Hi. Who was that? Okay, we had a little technical difficulties with the presentation, but thank you for all coming here. It means a lot. Had some kind words already from some people. Okay, keeping track of time. I gotta try to keep track of time and do this. So about me, I'm Bulbul. That's my name, but Chipperdoodles is my internet handle everywhere. So you'll probably find me under that one. Who am I? In context of what the heck am I doing here? Well, I've been drawing squiggles all my life. From the abstract art you do when you're a kid to the abstract art you do when you're a bored teenager in college class, and then you stain your shirt with Sharpie because you just drew on your arm the whole time. All the way up to now. I just refined the squiggles a little bit. Before I got into electronics, I actually studied in print, basically. It was graphic communications. I went to Cal Poly San Luis Obispo and got really involved hands-on. Learn by doing, classic slogan. That's stupid. Anyways, I was involved in pre-press, which is a lot of file preparation. You use a lot of different software to prepare print files for production. So that always stuck with me, a lot of knowledge. I spent a lot of time in the pre-press mines and checking out the back end too, because it was really hands-on. Fast forward, part I didn't write down was I was back on the ranch. I was working as a hand at the ranch shop, just doing mechanical stuff and whatnot, and somehow I got into keyboards, which got me into my first KiCad project, which was just a numpad that I etched out on a Link Sprite CNC machine that I got at Micro Center, something like that. And then it was downhill from there, down the rabbit hole. Good or bad, that's up to you if you like holes or not. Okay, and then after that, circumstances had me going out to Colorado. I got a job at SparkFun as a PCBA assembler. So I was a machine operator. So that means I ran the pick and place machines, the
selective solder machine, the AOI machine, and as well as throwing in with hand rework or not. So that actually helped me refine a lot of my technical skills when it came to assembling electronics. I had a little bit of knowledge, but yeah, I was really bad before I started. Came out pretty decent when I finished. But what they didn't teach me there, I learned on my own, was a lot of the actual electronic stuff. A lot of digging into data sheets, putting pieces together, learning how to route. When I was back there, they were still using Eagle. And I was using KiCad because it was free and open source. Eagle had a lot more barriers even back then. And KiCad was just, it was nice I got started without any of the legacy, like me having to relearn things. So it was, I think, I don't remember, it was around like 2016, 2017 when I started. Okay. Oh, I also wrote an article in Make that came out last year. I was really happy about it. It was about batteries and some different energy storage stuff. Also, I can't see right now because I fogged up my glasses. Woo! Okay, next one over. I established Chipperdoodles after I quit SparkFun. I haven't actually sold anything proper yet. It's mostly to friends and stuff like that, but hopefully one day I'll have some boards to actually sell. But I made a cool logo, and that's really what matters. Okay, so let's see, how we doing? Okay. First, I wanted to talk a little bit about Anwar. So this is my project that I have with Crowd Supply. There's a lot of history behind it. I've actually been working on this for like 4 or 5 years. I'm just kind of hit a limbo with a lot of stuff. But it started as a gift for my partner at the time. I had this crazy idea. And it was print related. While I was working at SparkFun, I was just like, you know, PCBs are just very high resolution reproduction processes. I've seen people do art in the silk, but right, why not in the copper? That's where you get the real detail. So I just wanted to see what I could do. So I had some ideas for a gift, and that kicked off. I had no idea what I was doing. The first circuit didn't even work. I don't even know what I was trying to do. But that didn't stop me. And that, excuse me. I had to swallow barb. To burp. Yeah, so while I was at it, while you're printing and making art in copper, you can carry current through there. Why not? And it led to the very like fun idea that like you got literal power flowing through your art itself, literal electrons flowing through there. You can hope. It depends on how you route it, but there's guaranteed to be some bouncing around there. Okay, so a lot of my recent art has been face plates for Anwar. So what Anwar is, well, first, Anwar in Arabic is a collection of lights. It's a plural of lights, but kind of many light. It's a nice word. My friend suggested it to me, and I decided, you know what, that is a really good one. So Anwar, the Crowd Supply campaign is for these little amulets. The project itself is like a 2-piece design, sandwich design. What I did is I figured out a whole bunch of stuff, which is another talk, about figuring out what power source to use, what components to use, changing my mind multiple times, back and forth about where to put what and what do I actually want to do with it. But so, wait, there's a laser pointer. Wait, how do I use this? This is dangerous. Light dot. Okay. Sorry, I was chasing the laser. So there's this baseboard right here, and you have faceplates that just have a small 10-pin header. It's a 1.27 millimeter pitch. So the same one as you'd kind of see for an ARM debugging, SWD debugging port, just low profile. So these plug into the baseplate. The baseplate takes care of energy storage, charging, programming, IC, and it breaks out 6 GPIOs to the header. And it's really nice. I'm using a tiny 1616. Really easy to work with, a great little chip, really can do a whole lot. And I program it over serial, so I have a WCH on there as well. But basically combines everything you need from a little dev board into a nice small size package. And the point is I wanted people to make their own designs. I wanted, because it started out as a personal gift from me to my partner, which meant a lot. I want people to be able to do that. I wanted people to make art designs that either make them laugh or, you know, have personal significance behind them. So that's where the whole faceplates come from. But to do that, I slowly kind of figured out how I was gonna make the art on there in the first place. So the journey with Anwar led to this kind of me drawing circuits a lot. Okay, so some basics. We have raster versus SVG. Now, in this talk, I'm going to be using raster art, which is not super common, but it works. SVGs are great. If you want to work in SVGs and you know how to, do it. There's really no reason to do raster unless you like what I say in the upcoming few minutes. SVGs excel when you need to scale or shrink. You design a file, the file size is small, you can make it as big or small as you want without losing quality. This is a great thing for print. And there's some great tools for SVG, yeah. So Thea Winters, a Winter Bloom, Stargirl, she made a great tool called Gingerbread. If you work with SVGs and KiCad, please look it up. I think she works with Affinity Designer, usually. I've messed around with it and Inkscape, and I think I had to muddle around a little bit, but do check the tool out, please, especially if you do SVG art. Also, KiCad has built-in Bezier curves now, which means you can do SVG art directly in KiCad if you wanted to. Bezier curves, it's kind of like a point-to-point mathematical equation that lets you curve the line based on some anchor points and stuff, right? Like that. Okay. Okay, so why do I do raster? I don't know, why don't I do anything? But more specifically, raster is actually really great at a set size. When I'm doing a circuit board, I know what size it's going to be. So it's literally designing for the size, designing for production. When you do an SVG, it's nice because you have a logo you want to reproduce small and big and this and that. Well, I'm drawing on a very set size circuit board, so there's really no problem using raster if you're not going to blow it up size-wise. If you're going to blow it up the other way, there is an issue there. Okay, and even more importantly, I think the main reason I started using it is because KiCad has a built-in tool for it. They have a, I think it's called image to footprint tool now. It used to be something else back in the day, but it's in the main project overview, you know, where you can say PCB or schematic or footprint editor, the project window. Okay. So this leads me to, so we had Anwar. This leads me to my next project, the Hamsa in Arabic is mother. So you hear someone saying Umi, that's my mom. It stemmed from Anwar because I was designing these two-piece boards. Anwar tends to be like, I have a specific, it's a sandwich design, you have a base plate and face boards, but I'm like, that's really for technical people who want to make their own face plates, who want to mess with the programming themselves. So I made Anwar easier for the tech people to program or people learning to program and stuff like that could do more with it. But it's like, I want to be able to give some things away to non-technical people or who just want a pretty shiny thing that I also think is pretty shiny and want to share. So that's what led to the Hamsa and what was cool about that is since it was non-modular, I could make it a single-piece PCB design, which is easier to assemble, less a pain in the butt. And that also made both sides of the PCB visible to the, you know, it's not covered up. So I was like, oh, finally, an excuse to draw both sides of the circuit. Because before, it's like, no one's going to see what's on the inside, you know? It's covered, it's masked, so who cares? I still kind of wanted to do it, but I'm like, I'm not going to spend the time on it. And then this gave me the perfect opportunity for that. So yeah, you can see this is the old two-piece design, so this is it together, and then this is the bottom and the front. So I made my traces look nice. KiCad has built-in, what's it called it? Track rounding and filleting and stuff like that, and fish fillets sometimes. No, they don't have that. Okay. Okay, so talking about the tools I use. So we're moving on to the tools I use. First off, I just want to say, anybody ever listening or watching this presentation, thank you. Thank you if you're an open source contributor to anything, not even just these two tools I use, just anything ever. I mean, it gives people like me an opportunity to use tools they might not ever be able to learn things they might not ever be able to, but, you know, just thank you. It can be a thankless job, but I really appreciate it. Okay, so first off, KiCad. It was my first ECAD tool program using, but I've used so many programs, especially in pre-press or design. Like, when you use one software, you can kind of figure out how other software works. A lot of technical jargon. So while I was learning circuits, it just started to make sense and whatnot. Yeah, and then, so I mean, nobody here doesn't know what KiCad is, right? Like, you all know what KiCad is. That's a better way to word it. Yeah, so the second one people might not actually know about, Krita. It's a free and open source digital painting tool for digital art. It's actually quite fantastic. It's not flawless, but it's great. When I was in college, I used Adobe because you get educational discounts. You have a friend in IT who gives you a code for the CS Master Suite, and that's on your computer for a little while. So I was using Adobe products, but after enough time away from college and also enough updates away to where CS5 is kind of not really supported that much anymore, and me just being fed up, I found Krita, and it was a great replacement for doing art. I was coming from Photoshop, which is like, you can do art in Photoshop, but it's not really made for that. But this one is artist first. So it's really good for digital painting and really solid. Okay. Okay. How we all doing? We keeping with? Okay, good. We'll do a walkthrough. So I'm basically just gonna walk you through how I do the art and what my workflow is in general. So first, I have a circuit first strategy, which is plan the circuit before you do the art. But okay, I lied. You actually have to kind of sketch an idea what you want before you plan the circuit. It helps you know what components you are going to use or the general layout it's going to be. So sketch first, circuit second, and then actually doing it third. So when we got KiCad open, so you can see here, actually I'll just mentioning the sketch. This is just something I drew down with the vague idea, and I started refining it in my sketchbook. I knew that I wanted LEDs here, here, here. I'm like, oh, I could do that with that. This is the general design. Okay. So that's the sketch, like kind of idea I mean when I mean sketch it out, like literally draw it out. And once you sketch it out, you kind of know what the circuit's going to be. In my case, I'm going to light up these 5 LEDs, et cetera, et cetera. But what I do then is Oh wait, this is the overview. Sorry. Ugh. This is the overview, so we'll go through it quick because I break it down more specific after this. But then you place your components, you pre-route the board. So I actually route it in KiCad before I draw it. And I'll tell you why in the upcoming sections. And then you actually do the art. So I use the pre-routed exported SVGs from KiCad as guidelines, really. It helps me keep track. You don't have to think as hard. You can be like, okay, instead of knowing that constantly referencing some pinout sheet and trying to hand draw it that way, you can be like, well, I already connected this pin and this pin in the drawing, so I need to draw a trace from here to here, that kind of thing. Okay. Yeah, so create your project. What the heck is my circuit going to be? What components do I need? So this is where the ideas and the sketch phases come in. I use a custom library I made. It's pretty simple to be able to make custom libraries in KiCad, but I just made like a square that is a placeholder for graphics. So I have something to link my schematic to my art that I'm going to import into the PCB view later. Yeah, and then the PCB start, board shape. So know what your board shape is going to be. You're going to need to make your edge cut layer. In my case, I've had the shape design for a while, so I knew what that was going to be. And then based on your rough sketch, start placing components, seeing what actually fits where, because now this is where the actual size becomes more relevant. It's hard to sketch unless you like trace in, 1206 or something by hand. It's hard to like just eyeball it when you're doing an artistic sketch. So this is where it kind of comes back to reality. You're like, okay, so I can lay these out. I'll look at my sketch. I'll put this here, put this there, and that. And once you do that, just route the board like you would in general. So yeah, this requires your basic circuit knowledge and stuff. I'm assuming you're there. We'll get you there later if you're not. But for the talk, we're going to assume you're there. Okay, so route the board both front and back, and use your sketch to guide where you want. So the thing is, while you're pre-routing, think about where you want your artistic traces to be, and move them around accordingly. You can just you can use free routing, or you can drag them, at right angles of things, something that's both easy to follow, or being like, I know I want the general flow of a curve to go along this side of the board, or whatnot. So you're kind of thinking about it while you're pre-routing. So it'll be easier to follow when you're actually drawing. Okay. DRC is optional here. It's not going to help you by the time we get the art in there. You can DRC your hand circuit or your pre-routed circuit just to make sure that your connections and nets are all connected. But after this, when we do our art and our art input, DRC won't help you. Okay, and then we export as an SVG. So in KiCad, we'll plot it out. We'll save each layer that we want as an SVG. Then we'll come back to it. Okay, so Krita, art time. This is important. This is all kind of important stuff for the document setup. If you don't do it right when you set it up, it's going to be messy later down the line. So DPI. So Krita is an art thing, so you'll be used to it like making a document. I'll do letter size or something like. That's the kind of settings you're going to be needing to pay attention to. So DPI, the higher the DPI, the more detail. But one of the downsides with raster art means file size is going to increase pretty high. I've gotten away pretty well with 600 DPI. I like working in 1200, but the file size starts to chug a little bit. This is ridiculous, but you can do it. But Krita can struggle with this. Your mileage may vary. So if you want something that might run a little bit nicer on your computer, you might even go down to 300, which is print resolution, but I suggest 600 and seeing how you handle it. It's, you know, hardware, software, kind of finicky. You gotta play with it. And then your physical size of the document, you want it to match your final board size, but give it, you know, plus or minus, well, plus 1 millimeter, just to have some room on your canvas. Okay. Color space, this is a weird one. Most of us don't think about this, but Krita is an art program, so it has color spaces in mind. And I bring this up because we're making a bitmap image. We're making a black and white image, no in-betweens. Well, the closest we can come to that for the color space is grayscale. So there's a little bit of in-betweens there, but this means when we convert it to the bitmap, there will be the least amount of information lost in the conversion because you're working with black and whites instead of colors. Colors will be interpreted differently in a conversion shade-wise. So it'll be better to work in grayscale as the color space. So once you created your document, you'll import, I just drag and drop, but you'll import each layer SVG and then center align them to your canvas. So this is where I'll import the edge cuts, I'll import the back copper, I'll import the front copper, and I'll layer them accordingly to kind of like you would be used to looking at them in KiCad. And layer management, as any artist can tell you, is pretty important. You don't want to end up drawing everything on the same layer. Oopsies. Yeah. Anybody that's worked with these programs, yeah. Anyways, so import alignment, I kind of do it mathematically if I know the document size. I'll select all the things I imported. I'll move them by the center origin, so half of the document size and then half of the document height, and get them nice and centered, because it's not the most important thing, but it helps you place the footprint in the middle when it comes to making it a footprint. Okay. Layer organization, now it's draw time. That's my favorite part. I get lost in draw time for hours. Especially, I was talking to Joey about this yesterday. When you're so zoomed in, you think you have like miles of space, but I'm like, oh, I can keep adding a swirl here. Let me zoom in a little bit more. So that's actually one of the benefits of drawing at 600 DPI, because you can only zoom in so far. So it might stop you from zooming in way too far. There. Okay. So this is the art part. Experiment, have fun, use different brushes, and see what works out. I have brushes that I prefer, but one of the reasons I like raster art is it captures more the imperfection of my hand strokes. SVGs are very clean. And there's a lot of stroke smoothing tools out there nowadays and stuff, but when I'm drawing in Krita, the smoothing isn't super high. I can have control over that, but I use a Wacom pen tablet, by the way, just the Intuos for the input, because I like that hand feel. So that's one of the big reasons I like raster art, because it really feels more like I'm actually drawing it than if I'm doing a vector illustration. Okay. And one thing to keep in mind, small details may get lost. So it kind of takes experience to know what's too small and what's too big. But especially little circles, if you think about them, if they're going to be unmasked pieces of copper and it's a tiny little dot, that can just get scraped off really easily or something like that. So just keep that in mind. Oh, and tolerances, I'll be honest, I just eyeball it in terms of manufacturing tolerances. That's why having the pre-routed traces are really handy, is because I use them to kind of be like, oh, okay, so that's how many, 5 mils is. You know, you can change your brush size according to millimeters too, but brushes have variable strokes, so it's hard to keep track of. So I like using the pre-routed routes to tell how thick my artistic traces are, if they're too thick or too thin or too close together, kind of thing. Boop, ba-doop, boop, boop, boop. Okay, so the quality on the screen, I'm gonna try to make these slides available, at least on my website or my Codeberg, so everyone can see them. But these are just, this slide is basically an example of import settings. So for the amulet, my size is 36 by 36 millimeters. According to my own advice, it should be 37 by 37. And then I have the resolution cranked up for this one. And I saved it as a preset. So if you know you're going to make more than one of these or you want to try drawing different shapes, it's really handy to save your image size preset here in Krita. And then here is the color space. So you can see I have this grayscale model and then a grayscale, the default's fine, color profile attached to it. Yeah, so 1200 DPI, you can start getting sluggish in some programs. No reason to go too high. Depends on the level of detail you actually really need. Layer ordering helps a lot. So you can see here I have my SVG import layers that are, you know, recognized by the file extension. And then these are actually my drawing layers, front and back. And I habitually lock any layer that I'm not working on, just as an extra safety step to make sure I don't waste a lot of time in one. Okay, so like I said, SVGs act as drawing guides. Pre-routing it helps you just focus on the art, which is where I have a lot of the fun. So here you can see these are my pre-routed SVGs. So I have vias and traces and through holes that all serve as a guide. And then here's the back with the circuit with more of the ICs and stuff. You can see I made them right angles and stuff to help them be easier to follow at some points and whatnot. But yeah, so like if I'm drawing and there's going to be a big through hole there, I'll make sure that that's covered, like nice thick circle art, so it'll be a nice area of copper, and you don't want to miss the pads because obviously that's where your components are going to be. Okay. So this is a zoomed in section. So you can see here, this is the USB-C connector, but a little side note is you can either draw black on white or white on black. I think in this case I was doing white on black because it helped me see the difference between the pre-existing traces. But I had to put a little fill layer and make it transparent so I could see the white a little more clearly and the difference between the two layers. But you can see here, like this is where a giant through hole is. So it's like I want to make sure that the pad isn't sticking out awkwardly from the art or et cetera, that it all feels kind of integrated and flows with the traces. But yeah, so you can see that it's full of decorative, non-important traces. Like when I talked about the little dots disappearing, stuff like this might not make it. And I'm doing really simple stuff in terms of electronics. This is an RF. I don't really need to worry about impedance. I don't need to worry about high-speed traces. Even USB 2.0, you can get away with so much. I've hand-drawn 2.0 lines, and they worked fine before. So, yeah, so you can see this is where the inductor is and stuff like that. And as you go, I'm constantly making sure the trace I drew corresponds with the pre-routed trace. It's very easy to accidentally even like do an accidental brush stroke that might bridge things, or you get lost in your own maze and you connect the wrong input to the wrong output. So it's very important to just keep on top of yourself to keep checking that. Okay, So when it comes to time for export, you're basically exporting one layer at a time. Now, for the case of show, these are a little bit transparent, but if you were doing white on black, you would want these solid black, the layer behind the white, because, like I said, we're exporting as a bitmap, so we want it to view it strictly as black or white. So for each layer you want, in Krita, you will hide all the other layers visibly, like just take off the eyeball. And so I just want to see the front art or the back art, and then export each one as a bitmap one by one. Now, I'm doing plated copper only with exposed mask. This I'm mentioning because you can do a mask layer as well. I'm just not covering it immediately, like for this art. But you can do some wild stuff if you want to work with the mask too. Okay, so we're going a little, what time is it? What? Let's check my time. Okay, we've got 20 left. Reminder to set up your future footprint library. So you're gonna need a place to store the footprints for KiCad that you're gonna make. And you're gonna be able to want to tell KiCad where those are. Otherwise you'd be like, I made them, but I can't import what are they? I don't know. So that keeps in mind. That's a lot of just, telling file path where thing is. Okay, so here's what it looks like among the other ones, the image converter. It says convert bitmap images to schematic symbols or PCB footprints. You can make schematic symbols out of this too, which is neat. So if you want it to look like the artwork that's going to be on the footprint, you can do an extra step and import one as a schematic symbol. Okay. So remember what DPI you chose or what your final size is, because there will be an option in the importer tool. You can't really see it in here, but it lets you drop down to select size or DPI. And if you know the DPI, it's really easy. Just put that in. It should line up with what size your board is, provided everything was right and that the field text updates for you. Okay. This KiCad 9 saved me so many extra steps of work because before this, you couldn't export using this tool to a copper layer. I don't know why. So I had to do a bunch of extra steps where I'd open up the file in the text editor, copy, paste, find and replace whatever I exported it. So say I exported it as a mask layer, I would have had to find and replace f.mask with f.cu. It was a lot of little steps that were just really, what's the word? Tedious. Thank you, and annoying. Tedious and annoying. So yeah, but now we can just say, hey, I want this to be the front copper, and it works. It's great. It saves me so much time, and cut out like 20 minutes of this talk. So in my case, what I'm doing is I want my art to be the copper layer exposed. So I'm going to need to have a mask layer on top of that. That is that image, so it gets plated, because I want it plated. For the Hamsa itself, I'm using the After Dark, which means there's a transparent mask, so I didn't do the mask layer. But if you come up and you see I have another white and gold one, that one I needed a mask layer to expose the traces to get them plated gold. So if you want them exposed to get plated gold, you make a mask layer with the same file. Like just open the tool again and load the file, export this one as, name it .mask. So once again, know wherever you save these, move these into your library folder. And there's one little step you'll need to do is edit the footprint, because there'll be like a giant reference silk screen somewhere in the middle. You can either do this in the footprint editor for the library, so it removes it for everything, or if you're already designing your PCB, you can just edit the one that's tied to that PCB file. That doesn't change it in the library. Whatever, I'm usually lazy and do that. Okay. So round 2, we're back in KiCad. We made our footprints. Now we go back to the schematic. We link the placeholders we made to these footprints. Then we open the PCB view. We import the new footprints. We got to place them. This is where it's handy if they were centered, making it just like I'm going to center this on my PCB right there. Okay. If you have a really high resolution one, KiCad can chug, at least in my experience. I haven't really dealt with it lately, but I've had some pretty dense designs just chugged, and I end up just hiding the copper layer when I open those files again because I didn't want to deal with it. But just as a heads up. So what I said DRC wasn't going to help you, it's at this point. This point, you're relying on yourself to have made the correct connections. So that was really, you just really have to keep on top of yourself. There's not much you can do. You can label certain copper as different nets if you want to, but that's a whole lot of added work. Like you can manually like label different copper parts as different nets, but oof. Yeah. So, and then double check that you've aligned it right, because it's like, oh, if it's a little bit over, it might be hard to say, like, I draw too close to the edge. You can tell in this one, I drew too close to the edge. So my other designs, I'm like, I gotta come back from that a little bit. But yeah, and 3D viewer is really handy in KiCad. I'll use it, especially if you forgot to do the silk screen. Like if you forgot to remove the giant silk screen and you open up the 3D viewer, you'll see like a giant G3 or something on there. But it's super handy. I love just opening 3D viewer and just being like, ooh. I haven't ordered these yet. It'll be a while. I'll just look at it in the 3D viewer and be like, yeah, I like this. This is gonna be good. Okay. Here's an example of just what KiCad looks like when I'm working. So this is the back copper, and you can see here with the combination of the pads, but with the artwork overlaid over it. So it's just a view of what it looks like. Here's those 2 socketed through holes here. You can see how the art kind of extends past where their area is. You can see like little vias here or there. You know, I try to beef up the copper around a via just to make sure it's not, it's functional. Yeah, let's see what's next. I don't even remember what, oh yeah. So after you double and triple and quadruple and quintuple and hextuple, that's probably enough. We'll stop at 6. And then you export it as you would any other board. You know, upload it to your board house sites or whatever, and wow, look at that. Wow, you drew a circle. Wow, pat yourself on the back. It's really cool. You don't have to go as nuts. This is just me getting lost. But here, we can look at this and see what kind of small details might not pan out. Like, especially like how dense it is in here and smaller. I know I had one board where my signature, so okay, here's my signature right here. There's supposed to be 2 dots for the eyes, but 1 dot didn't turn out. You know, like it just didn't make it. Rip. Little dot, we'll miss you. But yeah, another thing I wanted to say, I forgot to throw this in there. So the import, you're actually turning the bitmap raster art, when you import it to KiCad, back into, it's not exactly like a vector file with Bezier curves, it's just lines and points. But it's kind of like, has anyone used Adobe Live Trace? It's like, it was a tool in Adobe Illustrator where you can like try to turn an image into a vector image. And that could turn really messy, especially Live Trace was like that. This is kind of like a higher detailed one of those, So depending on the resolution you import it at, it could lose a lot of detail, or it could be a little funky. So you just keep an eye out that it's not going to be one-to-one to your hand art unless it's at a crazy resolution, at which point KiCad probably crashed. But visually, it will capture a lot of those details, especially with how small it's going to be on the board. So it kind of captures what's important, but keep in mind that some detail might get lost. Okay, I think that's it. Yeah, okay, this is just sources for the slides. Like, give credit where credit's due. Thank you to these people for making the stuff that I just grabbed from Wikipedia. Yeah, awesome, cool. Sorry, we have like 10 minutes maybe? So questions, concerns, complaints. Roland will take the complaints. Yeah, Carrie?
Okay, so you do the pre-routing, which is like normal circuit board routing.
Yeah.
And then you draw it. And so then when you import it back in, okay, after you've pre-routed and drawn the circuit, when you import the hand-drawn circuit back in, you like delete all of those pre-routes.
Yes, sorry, I forgot to mention that. Yeah.
I'm just trying to kind of like wrap my head around this. And then you just import the image and you're like, yep.
So like,
hope it's all good. And if you were to look at a rat's nest at that point, it would just be unconnected lines everywhere.
Exactly.
Wow. You are so bold. That is amazing. I'm super impressed that your boards work. Like,
right? Me too.
That's amazing.
What the heck? Yes.
Can you do SMD assembly with a rastered board like this?
I did it at home, yeah.
But like, will a JLC put parts down?
Okay, I haven't done it at a board house, but all the files really, they'll be okay. The only thing you might have trouble with at a board house, if your art they get too picky with their tolerance to say, no, we won't run this because these tolerances aren't good, so we can't guarantee that it'll be electrically good. But in terms of assembly, I mean, all the pads and stuff are there from your component, so it'll make a perfectly normal stencil and a placement file and stuff. So you should be okay for the most part. The tricky thing might be them saying this is too offensive to our tolerances, which I get it. But yeah, thank you.
I do a lot of this, I guess, and I have noticed that grayscale images, does Krita have a 1-bit mode? Because that can be faster, and you can't get grayscale in your silkscreen layers, etc., unless you want to dither. So
I have to look into it, but if you can, then that would be the way to go for sure.
Yeah.
Yeah. Awesome. Thanks. Good input. Alex.
Thank you. Awesome talk. Amazing.
Oh, thank you.
So cool.
Thank you.
I noticed that on the Khamsa you're running into the same issue that I've seen before, which is I want to make something with really nice, tight, sharp edge cuts. And up in the top there, I want to be able to get in those corners and make it all nice and sharp, but it wasn't, and I think that that's something that depends on the house, like, how tight they can route it.
So like here?
Yeah, exactly.
Okay,
and I'm wondering, like, if you've looked at all into different houses and who might be able to do tighter ones, or are they all the same, or?
It depends on their tooling. So they'll have like an end mill size that they'll tool with, and so in this case, so I got these done at Osh Park. Woohoo! With their After Dark. I've had various experiences, but I'm too lazy to change the design, and I'm totally okay with how they turned out. So, but yeah, it really is a house to house what their end mill tooling is, and if they're like just like this is our, prototyping line, we're not going to bother trying to make it a nice cut, kind of thing.
Do those like houses post what kind of like tolerance for the cut that they can do, like on their site? Like, is there usually somewhere?
Yeah.
we can see it?
You might have to look for it, and it might be only available as like, these are the bit sizes for our end mill. So like, if the radius of this is, or of the bit is bigger than it can get into, that's as far as it's gonna go. Okay. Anybody else? Looks like we're good. Okay. Thank you so much for coming. Thank you. I appreciate it. If you want to, I think we still have some minutes. If you want to take a look at some of the boards I made up front, please stop by and we'll do. All right, y'all have a good rest of the teardown.